Okay, I think we're rolling. Sweet, 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 sweet. Everything looks good. I can see myself. Very nice, very nice. I decided to throw that that tunnel effect just, you know, in the background and rearrange the interface a little bit. Hope you like it. So I just wanted to quickly just mention some things. First off, okay, there seems to be like a lot of what's the word? The idea that Web3 is somehow, because blockchain is considered more secure, that it is more secure, and that distributed databases and things like that are a good idea. So the thing is that the first thing you have to realize is that both of these technologies, distributed databases and Web3/blockchain technology, they were completely separate things. They evolved separately, and only recently, you know, has blockchain technology gotten to the point where it could support something like that. But compared to just having a centralized database on your project, for instance, because, you know, your project, you do want it to scale and everything like that, but centralized databases, you know, MySQL, literally the enterprise version, supported Facebook until it grew to a scale that is so big that I don't think that most people would ever reach in today's internet, unless you had some sort of a special Riz. So here we go. So I just, you know, I just wanted to like show this and then like walk through the steps or whatever. And the idea of this prompt is compare and contrast the security weaknesses and strengths between two paradigms of a distributed database and a central one. I misspelled and. Use some standard metrics and highlight specific architectures or stacks which would be most secure for both paradigms. So these are the key metrics: data confidentiality, data integrity, availability, authentication and access control, network security, and resilience to attacks. Okay. Now, this might not end up how you think it would if you came in here thinking that, you know, Web3 is the hammer that hammers in everything into everything else. You know, the be-all end-all. It is not the be-all end-all. It is simply one more technology, and it has its uses. Blockchain has its uses, and those uses are basically a niche. So, distributed database. Strengths: availability, resilience to attacks, and scalability. Right? They have the different nodes, and then there's, so first off, without blockchain, there's these two architectures, Cassandra and CockroachDB. The distributed nature makes it harder for an attacker to compromise the entire system, right? Resilience to attacks. Nodes and systems like Ethereum or IPFS work independently, creating redundancy and reducing single points of failure. Great. Scalability. Distributed access like MongoDB and DynamoDB scale horizontally. You see, these existed before any of the blockchain stuff, before Ethereum. MongoDB and DynamoDB, they scale horizontally, making them suitable for environments where security measures must adapt and dynamically as data grows, right? So the other thing is now we get to the weaknesses, okay? There's a lot of complexity in security management across multiple nodes, that increases complexity. And in programming, when you have complexity, what that means is that, like, so essentially complexity is not good in your program, right? A program that is finished and is complete and is working is a program which has accounted for, let's say, 98% of all possible situations or states of the program that could happen, right? And what is a state? Well, okay, let's look at a state machine, right? So a normal program, like any program that you sort of see me writing in Python or most languages, these are finite state machines, okay? You've got a Turing machine, which is literally the, that's like your computer, essentially. Push down automaton, I don't actually know what that means, I'll be honest. finite state machine. That is what I'm talking about. And then combinational logic. So, oh, FSA. Oh, okay. They're automaton if it's plural. Okay, so, okay, that makes sense. A plural finite state machine, if it's working in conjunction with other machines, then it can be considered an automaton. Okay, so the idea is it's an abstract machine that can be in exactly one of a finite number of states at any given time. Okay. Now this is exactly how they model reinforcement learning models. Reinforcement RL state action space. So in the RL state action space, you have the agent and then their environment. Okay. They take actions, they get a reward, and the environment is essentially their state. So state, action, reward, next state. This is how reinforcement learning works. So you see the current state, okay? You take an action and you get a reward. Then you get to the next state. So this thing right here, this is actually like not fully straightforward of an example, but what essentially happens is that you go, okay, I've got a state, and then I've got the state that I'm trying to predict, essentially. And then reinforcement learner gets pretty good at predicting the next state, and then choosing an action based off of that. And whatever happens after that, they get a reward. There can be sparse rewards, which is like, think of it like training a dog. Okay, little reinforcement learning agents are essentially like the whole idea of it is kind of like training some sort of an animal, right? Where it's like the Pavlov thing, right? You're training a dog and you teach it to salivate or whatever when it blah 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 blah, because salivation is the thing that when a dog salivates, it's like expecting a reward. So that means it's already predicting like what action it needs to do in order to get that reward. So this is what it's predicting is going to happen, and this is the reward that it actually like gets. So it's predicting this much reward from taking this action at this state. So that's why you have 0 and 1 here, right? You have state 0, which is the current state, and action 0, which is the current action. Then you get a reward, etc. Anyway. So that takes us all the way back here. Network. Okay, so what is all? You might be like, wait, Nate, what does that have anything to do with any of this stuff right here? Well, let's just walk back through it. I was saying that it was like a finite state machine, right? So a finite state machine is essentially a program. If a program is a finite state machine, then yeah. So if you have a finite state machine, this is what it is. The complexity issue. Okay. If you have a finite state machine, essentially what happens is each time exploding dimensionality problem. The curse of dimensionality. There we go. So the more dimensions you add to a problem, the more space that you create as possible states. So the more dimensions that you add to, so like for instance, let's say that I have a machine and I have one state that is turned on, and I have another state that's turned off. That machine is really easy to understand. The only logic that you ever have to make on that machine is what's going to turn it on and what's going to turn it off. So you're thinking about the logic that is the transition between the states, right? That's kind of like what the action is. If you take this action, then it will allow you to transition to this next state that you're seeing will get you a reward. So the reinforcement learning agent, what it tries to do is it tries to maximize its reward for the next action that it takes, and it relies on a policy system that kind of like keeps track. It's like a table that keeps track of like, okay, these are the states, these are the actions that lead to the highest reward in this state. Okay, it's a bit different from normal like the encoder decoder architectures that most people are focusing on right now. All right, so, okay, back over here. Complexity and security management. Maintaining security policies across multiple nodes increases complexity, particularly for ensuring ensuring synchronization and consistency across distributed nodes is super fucking hard. Okay, for example, eventual consistency models, you have to run, okay, risk short-term data integrity issues. What they're saying there is that they have to make like this prediction model to figure out what essentially is going to be a balance between short-term data integrity issues and whatever it is that they're doing over here, which saves you long-term data integrity or something, which has to do again with synchronization, because it's like, you know, imagine if you're calling somebody up every 10 minutes and giving them an update on what's going on, right? So they're going to be synchronized with you on like what's happening with the situation, right? But then let's say that like instead of doing it every 10 minutes, you do it once a day. Well, for an entire 24 hours, that person is going to have yesterday's idea of what was going on. So that's the whole problem with that. And you know, what interval do you use and all these other things? There's so many factors. It makes it so much more complicated. Network security risks. Distributed systems rely on extensive inter-node communication, which can introduce vulnerabilities like the man-in-the-middle attack or interception unless secured with protocols like TLS. So obviously, some of these guys do that stuff. Authentication challenges. So in systems like Apache Kafka or Kubernetes clusters, ensuring secure cross-node authentication can become an attack vector if misconfigured. That essentially means you got to read the fucking manual and you have to figure out, okay, what is the exact configuration I need for the security that I'm doing, right? And you know, nobody can tell you that. Maybe you can put in your exact security needs to ChatGPT, but again, you know, if you're doing that with a model that's like one of these companies or whatever, then what you're also doing when you're putting stuff into this is giving it training data. So good luck having your training data like be spat back out randomly to some 14-year-old kid who figures out a hack to get GPT to, you know, output that. CockroachDB focuses on strong data consistency and built-in TLS encryption. MongoDB with encryption and REST transport ensures confidentiality in distributed setups. So, yeah, I would say CockroachDB looks like a nice bet. I have used MongoDB. I don't really like the way that, I don't know, the whole, I don't know. I guess I got used to this like whole like half database, half data store type of a thing deal. And now that I've used like vector embeddings and retrieval augmented generation setups with like, yeah, semantic search essentially. I'm used to this more, but at first I totally resisted MongoDB because it was like really being sort of like pushed in everybody's face back when Node was first coming out and like jQuery was super popular. That shit was like, woof. For me as like an old school guy, it was kind of unbearable a moment because you know, I was like resisting the change, but eventually, you know, I accepted it. Blockchain platforms, Hyperledger Fabric, secure distributed ledgers with consensus mechanisms and cryptographic techniques, right? So Hyperledger Fabric, what does it actually do? It adds an extra layer, which is actually what is another extra layer of complexity on top of the shit that you already have to maintain and debug if something goes wrong. Because one side of programming is, you know, the stuff that you see me do here, like right now while I'm setting this up, is the stuff, you know, that's like the stuff, that's the cherry-picked examples of like when it's cool to program. When you're just like, you know, just riffing on code and like going all in. But then when you are actually having to maintain your code, that's all the boring stuff that like just takes effort and dedication to, you know, just doing the job that you said you were going to do. And it takes you pushing yourself through, just like, you know, you're not doing cool shit right now. You're doing absolute shit that needs to get done. So, all right. Anyway, that's also why I'm going to make this short because I got plenty of shit to do today. That has to do mainly with maintenance and stuff. So I just wanted to say this though, because this is like, for me, this has been a very big question from people that I've got. Centralized database. So the strengths of a centralized database, and first let's just go over the weaknesses of a centralized database, because I feel like the weaknesses are something that is like an attack vector of the people who say that blockchain is better than centralized databases. Now, now let's see. I mean, first off, it totally depends, right? Like, you know, sometimes you might want to have control over what actually happens on your database, or sometimes you just don't care. You're just like, I don't care. You know, put like in the Bitcoin network, you could stick a video game on the ledger if you wanted. You know, people have done as much, but you know, what's the point of it? I don't know. A centralized system has a single point of failure. If the database server goes down, data access is lost, right? So yes, obviously. Resilience to attacks are more susceptible to DDoS attacks, which is distributed denial of service attacks. So if you use a distributed system to attack a centralized system, you know, it's like a whole bunch of people ganging up on one person. Or physical tampering, since all data resides in one location, which, yeah, physical tampering is literally, that means somebody can come to the place and literally take your server, or you know, hook a USB into your server or something like that, and then you're fucked. Scaling centralized systems is more difficult and usually vertical, limiting the ability to handle large-scale distributed workloads, okay? Now, let's look back over here at the strengths of the distributed database, and you look at scalability, and it's like, yeah, distributed databases like MongoDB scale horizontally, making them suitable for environment or security measures. So, cool. Here we got a, so here's the best secure architectures. I really love PostgreSQL. I'm a big fan. And PG Audit, yes. Offers strong access controls, encryption, and auditing. I recommend like something like Firebase or Supabase if you're doing distributed, like not distributed, but if you need a centralized database, but you don't want to have to worry about all of the extra security concerns that come along with hosting your own centralized database, then use a system that's already using cloud servers and has their own dedicated security team. So, Oracle database with transparent data encryption, TDE, provides comprehensive security for centralized systems. MySQL with Vault integration for key management and secure credential storage. You know, this worked, like I said, this worked for Facebook for the longest time. Did Facebook have problems and hacks and stuff like that? Yes. But you know who else has problems and hacks? Like literally anybody who has people who are in charge of anything, right? So the problem is that like with the distributed systems, hacks and stuff doesn't happen. They totally happen. Can you do a 51% attack on a distributed system? Yes, you can. You know, so you can change. There's still ways to change ledgers, and especially if you're creating a system. Let's just say, okay, let's just put it like this: you create your system in a decentralized way because you think that's the way to go, and your thing doesn't get like way too popular. But still, there are some people who have, you know, put a lot of time and effort into it, and they like it, right? So you have like, let's say 1,000 users or something, right? That means that I only have to emulate 500 nodes. Like the same thing as a distributed attack on a centralized one, a DDoS attack. The same thing essentially, but a 51% attack, because you just have to have more than the amount of nodes, which are actually the nodes that are supposed to be verifying and validating the data. And once you have that, you have full control over the system. So that means a person that doesn't even have to be near you or around, right? Like maybe this whole part of like physical tampering thing might actually be a good thing, because that means the person actually has to like get up and try and find your server and go over there and do something to it. You know what I mean? Is that a weakness or is that a strength? It totally depends on the situation and what you're trying to do. So that's the other thing, is like anybody who says that one thing is better or the other thing is better is just a tribalist. They're just people who are trying to like get you to their camp, you know, unless they ask you exactly what it is that you're doing, and then they consider metrics like these, because those are the considerations that you need to take into, like, that you need to actually think about when you're setting up a stack. You know, if security is one of the things that you really care about, and also scalability. So this is only from a security standpoint. Now, scalability is not actually a problem. I mean, like I said, it depends on the level of scalability that you're talking about with centralized databases. Anyway, I just wanted to have this quick little chat with y'all just to explain that. because, you know, I've had that question before, and I think it's better maybe if I just make a video about it so that I can just reference to it whenever somebody asks. All right, so peace out. I'll be back streaming later on. Have a